All right, well, thank you for joining. I'm Dr. Patty Skinkis. I'm Viticulture Extension Specialist and Professor here at Oregon State University. And I am going to be talking to you today about how to improve wine grape crop estimation. Specifically, I'm going to be focusing mostly on Oregon because that's where I'm located. And a lot of the information is general on how to do crop estimation, but I get into specifics that have to do with some of the work we've done in my lab here at Oregon State University to help make wine grape crop estimation even better. So as we go through today, if you have questions, it would be best if you type those in the Q&A. There should be a one called Q&A, and now I'm not seeing it. That's normally where we would put there's a Q&A section. If you don't see it in your toolbar, you can click the more, but that's where I would like you to put questions. And as they come in, I will address those. Because I don't have another host, it might be a little bit hard for me to monitor that, but I will get to them in the end. So feel free to use the Q&A. The nice thing about the Q&A, if you don't want to be known, you can anonymously post your question, and then I will address that for you. It just helps manage the questions that are coming in better than if it gets lost in a chat box. So please use the Q&A feature. You won't be able to see or hear other people. That's been disabled. So if you don't see that, that's why. But if you have a question, again, please use the Q&A feature throughout. Okay, so now here we're going to get started. So we started this Vit Now seminar series this year, just basically to help address questions that we typically see throughout the year, getting ahead of them by having these webinars and hopefully allowing people to ask questions on timely topics. So you might be seeing some other ones come through. We have one on vine mealybug next week. We had one on irrigation scheduling in June. So today's crop estimation, trying to get ahead of what people are doing there out in the vineyard. See, make sure I can get this to advance. So I think most of you who are joining today understand completely why we need to do yield estimation. It's obviously important to know what you have out there in the field for contracting purposes, but on a functional level, it's really helpful to determine how much we need to adjust crop load. So I got it started working on this topic because I do a lot of work in yield management, but decades ago, or 12 years ago or so, that when I started doing yield management research, I did a survey of the industry and found that 89% of Oregon producers were doing cluster thinning. And most of that was on premium varieties and especially Pinot Noir, in part because they were getting down to certain yield targets or crop load targets that they wanted to achieve, and they had to know how much to adjust. And in order to do that, you have to be able to know what is out there. And so that's needed at the crop. The crop estimation is typically done at the lag phase because cluster thinning will happen shortly after that. And of course, there's other reasons that people want to know yield. It's not just to reach a target, but it also is to know what capacity you have in the winery. So tank capacity, or how many harvest bins you need to purchase, or barrel purchases. All of those supplies throughout the production stream need to be determined. So it's really critical. And yield estimation can be done at various times during the year, and it's best if it's collected at different times and used as a composite to inform what yields are looking like. But typically, yield estimation is quantified pre-harvest at lag phase. That's the main time that people are doing this. But we recommend that you start as early as pre-bloom. And then you can also do some validation steps post-veraison. So I'll talk about each one of those here today. So the first step in yield estimation, doing it early. So this is something that is really helpful to get an idea of what kind of level of fruitfulness is out there. And it does change over time. Not huge changes, but it does change. So yield is obviously informed by how many clusters are out there in the vineyard, as well as the cluster size. And what we do in the vineyard, how we prune it, how we shoot thin it, how we crop it, it really makes it a an impact on yield. But early season, if you're going to start doing counts, you need to know bearing vines. How many vines in a vineyard block actually are going to be producing fruit? Get that number out of the way early. That can even be done during dormancy. The second thing you can do is getting your cluster number per vine. An alternative way of looking at this is you can also come up with fruitfulness, which is considered the number of inflorescences per shoot. And that you can get at the same time that you get cluster number per vine data. It just means you go out and collect your number of inflorescences or clusters, and you divide that by the number of shoots. So you're collecting shoot count and cluster count data before bloom. Obviously, you want to do that after you've done shoot thinning. And that gives you an idea of what kind of fruitfulness on a per shoot basis do you have, but also you can start to do some basic calculations of what kind of yield is out there. Obviously, if you've not gone through flowering and fruit set yet, then the cluster size is not going to be determined, but you can get basic counts. You can estimate your cluster weights by using historical farm data. If you've got it and you know that a given block is generally going to be a 120 gram cluster or a 350 gram cluster, depending on the cultivar, then you can go ahead and use it. Or if you're not sure, you can use literature or reports, journal articles to figure that out. But basically, you can go and get your basic estimates by looking at your number of vines per area, multiplied by the number of clusters per vine, and your estimated cluster weight. Now, there's some assumptions that come into this, that you get good fruit set and you have to have historical data. And so most people don't do this step, but it's helpful to do that early season step. So the lag phase estimates, those are the most common. And this is why I'm doing this webinar right now in the middle of July, because I know that's what people are starting to do already or will be doing shortly. And this is really hinges on some basic principles of cluster or berry development at what's called the lag phase. Now, the lag phase of berry development is part of this phase 2 of berry development. So in this diagram, we see that it's representing the development of the berry. So this curve right here is what they call that double sigmoidal curve. And this is commonly talked about. This is a textbook kind of summary. This is not what a real cluster, or I should say berry, looks like. It's a little more messy than this. But this is a schematic to indicate after we go through bloom, there's a very rapid increase in the berry weight. So in this case, they're using berry volume. You could do this as weight as well. There's a very rapid increase. And then there's this plateau in the berry size before it starts the second curve upwards at around veraison. And then that continues till harvest. So what happens is in this lag phase, this is what people have really tried to target for crop estimation. And the main reason is because the berry is about half of what it will be at harvest. So it makes it simple math. It also means that you can get out in the vineyard and start collecting data from clusters and feel like you have some stability, because prior to this stage, there is very rapid development. And then after that phase is very rapid development of the cluster. Now, as we continue through looking at using this lag phase time point, what has to happen in the vineyard at this time to do that crop estimation? Well, first you have to know your number of bearing vines. Hopefully you would have already gotten that data by going to the vineyard and collecting it during earlier stages of the year, or even during dormancy, for example, missing or dead vines. Then you have to get out and do cluster counts. So these cluster counts per plant, you could have gotten earlier as well. You don't necessarily have to do it at this time point, but a lot of times it's just easier to see the clusters now than when pre-bloom, when you're doing your fruitfulness counts. Then you have to get cluster weights. So this is where this hinging point on lag phase becomes important, that a lot of people are very concerned about getting out at lag because their clusters will be half of what they'll be at harvest, or that's at least the general thought. And then you use an increase factor. Now, the simplistic increase factor would be using a multiplier of 2, right? Because your cluster is about half of what it would be at harvest. But the reality is it's not so simple, because that curve I just showed you in the last slide is based on the berries development. That's not the cluster's development. The cluster is, of course, a composite of berries, but it's not going to be exactly the same for the cluster weight. So what kind of increase factors can we use? And I get this question all the time, every year, starting in July and into August, people will ask questions about what increase factor could I use? Well, there's different ways that you can come up with increase factors. There's vineyard-specific increase factors that require that you collect a lot of data, which means that you're collecting data on the cluster weight at harvest, as well as the cluster weight at leg. And you take the harvest cluster weight, you divide it by your leg cluster weight to see how much did that cluster increase in size. Now, the reality is you can do this, but many people don't. They're just too busy to be able to get that harvest cluster weight. Those of us who are doing research, we can do this because that's our business to collect data and help people out. But when in practice, a lot of people aren't collecting their own harvest, own cluster increase factors. Now, for most growers in Oregon, they use what we call the Oregon method of doing crop estimation and increase factors. And so this is a practical vineyard and winery article that was written by Steve Price a number of years ago. And he was working in viticulture extension and developed increase factors for Chardonnay and Pinot Noir. And that became the standard at how growers do crop estimation. And so there were some assumptions. Some assumptions occur if you use the standard Oregon method, is that you measure your clusters at leg phase and that you have roughly a doubling of cluster weight. And more specifically, Steve Price found that the mid-leg phase of Pinot Noir was at 55 days post-bloom, and that it correlated to 75% hard seed tips. The timing of bloom was unclear in the methods, but the increase factor that he proposed and that many people use even today is 1.8 to 2 as the increase factor for the cluster weights at leg. Now, in this paper, he talks about the sampling size should be 4% of the vineyard and as much as 30% of the vineyard if you have highly variable blocks. I think that's a little bit more than most people would admit to wanting to do at 30%, or getting a sampling of 200 to 400 clusters per block that you evaluate. So this is kind of the status quo of what we're working on, at least for the increase factors for Oregon. But I want to talk about some of the crop estimation pitfalls. People weren't still happy with, just what they were always doing. There were problems. And what could be the problems of why their crop estimations were coming back not quite what they would like? Well, first of all, it's difficult to determine when leg phase occurs. It's not visible like bloom or even bud break. It's not as easy to determine as veraison in red fruited varieties. It's difficult to determine when your specific block is actually at leg. Second, we don't really know how long the leg phase period is. We just assume. And then, of course, that timing then throws off the proper increase factor to use, because the principle of leg phase was using a very simplistic increase factor that applies for that snapshot in time. So that's one part of the equation. The second part is just not having enough sampling. So insufficient sample size, not doing a good job of getting a good random sample or a sample that's representative. Sometimes people don't adequately account for non-bearing or weak vines. And then sometimes there's a misrepresentation of the cluster. So for example, if you leave wings on or you remove them by the time you harvest. So to improve crop estimation methods, first and foremost, I want people to understand where the most variability shows up in the equation. Even if you do the best job that you can do in quantifying cluster weights or going through your vineyard and getting data, the reality is cluster weights are highly variable. So this picture I show here just shows you in the same vineyard in a small research plot how much variability exists. And these are all clusters we use for our research that were collected to quantify cluster variability. And we see that there's a lot of differences in the number of berries per cluster. And as a result, just cluster size. Now, what doesn't change as much is berry weight. So berry weight is more genetically driven by the cultivar. And obviously, if they're not severely water stressed or damaged, the berry weight is going to be relatively consistent. The cluster weight variability enters in by differences in berry number, which is related to flowering and fruit set. So when it comes to sampling, we know that the clusters are going to be variable. So what do we do in getting an accurate sample? Well, the biggest thing is to collect samples across space that represent the site and the site's variability. So going through the vineyard and knowing the weak spots or the really heavy spots and making sure to sample there in a percentage of your total clusters or vines that you collect in those areas that represent maybe, for example, if 50% of a vineyard is going to be weaker than the other 50% of that vineyard block, then you would sample according, like half your clusters come from the weaker area, half come from that other area. And that's an extreme. I hope you don't have that much variability. But if you have maybe a 10-90, you do your sampling across that variability to ensure that you're getting a representative sample. Also, make sure you get sufficient number of clusters. In this case, you want to consider doing whole vine sampling rather than just grabbing individual clusters. And I'll talk about that a little bit more. So you want to collect your data by blocks. So here's a vineyard that is actually broken down just for the sake of sampling to say, we know there's variability here. We're going to break down 1, 2, 3, and 4, even though this is really functionally only 2 vineyard blocks. And that is one example of how you can kind of deal with the variability. So you count the data by these blocks, count missing vines, make note of those areas of variability, and then sample in those areas that are representative of the variability. Obviously, the more irregular blocks you have, the harder it is to quantify number of vines and number of missing vines and those sorts of things. Then have a sampling strategy for your cluster weight. So here's just a pictorial example of how I have here just said every 10th vine of every 5th row is going to be where we're going to collect the fruit. We're not going to, that's the randomness of it, is that you're going to come up to that plant and you're going to collect your clusters from it, or use that as your whole vine that's representing the sample. If you're going to do cluster weights, make sure that you collect clusters as randomly as possible, but keeping in mind to try to collect across the whole length of a cane or a cordon, because we sometimes see differences at the head of the vine versus the end of the cordon or the cane. The question I get a lot from people is, what is the ideal number of clusters to sample? That is something that's hard to give you an exact answer on, but I will give you some guidance in the next few slides. But I can tell you this, I like to recommend that people collect clusters from whole vines rather than doing individual cluster collections. And it's because the human eye wants to cherry pick. We want the bigger clusters, the ones we can see better, whether we're trying to or not. Typically, the cluster weights are going to be higher in those vines where you're doing, in those vineyard blocks where you just do cluster collections rather than just taking all what's on the vine. And when you do what's on the vine, you get a cluster count, and then you get the whole weight to get your cluster weight. So that's the preferred method. So I want to get back to that question of how many vines or clusters to sample. Well, this really comes down to how much time you have, how many people you have, and how much fruit you have. Obviously, if you measure every cluster, you'll have the best data, but you can't do that. Even the example of saying you have to sample 30% of all the clusters in a vineyard is absurd. There's no way you could do that very easily with, at least in the ways we do it now, from a standpoint of collecting cluster weights destructively. So I offer up this example, and this is an example of sampling technique, whether you use individual clusters or whole vines. And in this example, we actually use real data. So this is cluster weight. So this is representing cluster weight. If I went in and got 20 individual cluster samples, 125 cluster samples, and how did those compare? Well, right here, and this is across 2 years. So this is 2011 in the teal and 2012 in the gold. And in each of those years, you can see it didn't matter if I got 20 clusters or 125 clusters, the mean and the error is about the same. They're not statistically different from each other. So does that mean you only need 20 clusters? Not necessarily. In this case, we were in a commercial research trial where we were collecting data across the whole area. And I took randomly from our data set, we had a total of, many clusters that we quantified and measured, but I took a random sampling of 20 clusters from that. And I took a random sampling of 125. And this is of the data, I should mention. So we were adequately sampling the space. And so if I randomly selected those clusters and those, there's no difference if you do a good job of sampling, no difference in the means for those cluster weights. Now, if we look at the whole vine situation here, we have 12 vines or 75 vines. And we see that really there's no statistical difference in the means of these cluster weights still, even with whole vines, whether we did 12 or we did 75. But the difference is the error bars are tighter when we did 75 vines. This is going to show that if you do a good job of spatial sampling within your vineyard, you don't need to do a huge number of clusters or a huge number of vines. But I'm not going to give a recommendation on how many vines or how many clusters need to be done, because that's relative to the size of your vineyard and the amount of variability that you have in a vineyard. And every vineyard block that you work with is variable. It's just more or less variable than other blocks. And the more variable it is, the more sampling you'll need to do to represent that space and get an accurate count. The other thing I want to point out here, these brackets up here, this goes to show no matter how much you do or how many clusters you get, the variability of cluster weight is real. You can't really change that. And that's why we have to do a good job of quantifying our cluster weights. Now, manual sampling is one of the things that limits us. Certainly, there's a lot of effort in place to try to improve efficiency and accuracy of crop estimation by basically counting as many clusters as we can with precision agriculture tools. And these tools are still in progress. They're not completely figured out, but this is just an image of two different applications. One is a camera that can scan the canopy and takes pictures of the clusters, and it's on an ATV. And here's an example of a mobile app that's being developed that can be used by using your cell phone to quantify berries per cluster. Now, there's been a lot of work done over, the last couple, 15 years or so on precision agriculture applications for crop estimation. I list some of those here, but we don't have anything that's field ready just yet. These procedures are promising at most about 3 to 4% accuracy, but people think that it's going to make things a lot quicker and easier. But the reality is you still have time involved and resources involved in image capture and then data processing of those images. And that's why these have not been mainstream just yet. Now, I do have up here the mobile app, crop estimation mobile app that's being developed. And if you want to learn more about this, my colleague Manoj Karki at WSU is working on this. So I have the QR code that you can check out about that project. But basically, it's scanning berries and trying to do berry counts per cluster. But I'm going to get back to what we can do now. So that's improving our manual methods for crop estimation for Oregon. And of course, not just Oregon. Those of you who are joining that are not based in Oregon, this is still helpful for you. And I want to talk a little bit about how my lab focused on cluster weight increase factors. And the objective of this work really came out of a lot of people asking questions about when is lag phase, what is the appropriate increase factor, and really focusing on really having to get fine-tuned yield targets. And I remember sitting in grower groups, and this is a picture of our Willamette Valley Vit-Tech group meeting, where we're talking about this amongst other issues. And it dawned on me that we could easily do work, easily is not is a relative term. I could easily do this work in my program to help the Oregon industry come up with better crop estimation data, specifically with increase factors. Originally, I started out with the goal of identifying when lag phase occurs, just testing what Steve Price found earlier and see, is this really valid? Can we use a day count, or should we be using something else? The second thing was to determine increase factors that we can use at lag phase. And then it dawned on me we could do much earlier estimates than waiting for lag, which is actually pretty late. So what we did was, over a course of many years, my lab looked at berry development curves for Pinot Noir and Chardonnay. We did 6 years of data collection for Pinot Noir for the model that I'm going to show you. Actually, we did 7, but one of the years, the 7th year, was a validation year. And for Chardonnay, we did 7 years. So the duration that we did this in was basically we went to vineyards from the BB size to pea size up to harvest, and we got samples of clusters, 50 to 60 clusters, and we did this 1 to 2 times weekly. And we did this throughout the entire growing season, basically from that, 20 days or 30 days post bloom until harvest. And we took a lot of measurements, took a lot of work. We measured cluster weights, berry counts, rachis weight, rachis length, berry diameter, wings, hens and chicks quantification, and seed hardness. We also looked at some of the indicators for berry ripeness. So looking at colored berries or softened berries, and then looked at sugars, sugar per berry, or Brix sugar per berry, and pH. So lots of work. And many, even some people who are listening today probably were in my lab at one time and helped collect some of this data. But what we did was we published a model for Pinot Noir that was published in 2022. And I'll provide the links for this to everybody who registered today, but this is publicly available. And what we found was, over these 6 growing seasons, which were very diverse growing seasons from a climate standpoint, we saw that there was very much a common berry weight development curve based on days post bloom. So that's what we see here. And this is the lag phase. So the lag phase, it's not a perfect, this double sigmoidal curve is not as perfect as that textbook depiction, but we see that there is a lag phase that occurs, but looks here between days 40 and 60. But we quantified that more specifically. And it's pretty conserved between some of the coolest growing seasons in that time to some of the hottest. So 2011 was our coolest, 2015 was our hottest. And we can see that it falls on a very similar trajectory in day count post bloom. So what we found is that the start of lag phase was around 49 days after, and we very specifically called this post 50% bloom. That's what we were looking at. And that would be the midpoint of bloom. The middle was at 55 days, and the finish was at 61 days. Now there's an asterisk here for the 61 days because no matter the year, by the time we hit 60 or 61 days, that was the most consistent signal that we were done with lag. That's when we saw the start of veraison. And this is, again, for Pinot Noir, the duration ranged significantly. So it was 12 days on average, but it was a 6 to 24 day range. Now the 24-day range was in our hottest year, which was 2015. And we did look at timing, so thermal time as well as day count, and we found that mid-lag occurred at 1,000 heat units post 50% bloom. Now we did test seed hardness in the lab, in part because a lot of growers had said that they would determine when lag phase occurred by testing for hard seeds. And when I would ask about how they did this, it ranged from somebody just trying to use their thumbnail to bust a seed, to using a jackknife. And I would ask, so how many did you do? A range of 1 to like only a handful. So it was not very good and not very standardized in terms of scientifically evaluating this to be able to say, okay, 75% seed tips is going to be when we're at mid-lag. So it was not a good determinant of lag phase, even when we did the detailed analysis in the lab where we standardized this procedure. And the reason it was not a good determinant of lag phase is that our first hard seeds were quantified around 32 days post 50% bloom, and we had 100% hard seeds by day 61. And that range of 40 to 60 days, there was a huge, very rapid increase in percent of hard seeds. So a grower to functionally be able to figure out 50 to 75% hard seed tips would be very difficult. So we kept collecting this data, but it just reinforced that it's not a very good measure on a practical level to determine when you're in lag phase. But then we spent all this business about going in at lag phase and figuring out when it was, then we realized that, well, we don't really need to worry about lag, to be honest, because we can do crop estimation earlier. It can be done, and we can match increase factors to that developmental curve and get a more accurate picture of what is out there than guessing when lag is and then applying a simplistic increase factor. And so from all of that data, those 6 years of data that we collected, we put that together into a model, and we saw that the increase factors, when we looked at the weight at time of sampling during these days post cap fall, relative to the harvest cluster weight, we saw a very similar trend emerge for all 6 growing seasons. And this is what we came up here with the model, a power curve model for the increase factor for days post bloom. And then we also did it in thermal time post bloom. So growing degree days 50, base 50, similar curve, just different equations. So you could plug these equations in if you know your day count post bloom that you were collecting your samples. And so I see a question came in. So did the lag phase start much earlier in the warm 2015 season and then finish at day 60 post bloom? Absolutely, that's what happened. Veraison was not necessarily later, but things were pushed earlier with that warmer season, and it just had a longer, kind of an earlier start to lag, a longer lag period, and then Veraison kind of started as normal. So that was a great question. Just want to close out that question before I move on. So of these models, when we looked at them for day count post-bloom versus thermal time post-bloom, day count actually had a better relationship from a standpoint of statistical fit in the model than did thermal time. Both were good. And we're just looking at the mean squared error here. It's slightly higher. In this case, that means that it's a better fit for using day count post-bloom than using thermal time post-bloom. So this is what it looks like. You know, I don't expect people to know exactly how to take a curve like this and make it into something they can use. But what I did was I put it into an Excel spreadsheet that you can download. Now it says you can download here. When I make this spreadsheet available, or this slide set available to you, you can download it. But there is a link on our OSU Extension website that I'll show on where you can get the Excel spreadsheet. You click the link, it will download the spreadsheet. And in that spreadsheet, you can figure out your number of days post 50% bloom that you are, and it will give you the increased factor. So if you want to go out at 25 days post bloom and get your cluster weights, your increased factor is 5.2, for example. Or if you want to wait till you get to day 55, the increase factor is actually 1.7. Or day 50, it's 1.9. So that's how you would use this. And I'll show you a little bit more about this. So where to get the crop estimation spreadsheet? It's publicly available, as I mentioned. So if you go to the OSU Extension website for wine grapes, which is the link here, you can click on the icon that looks like this. It says Pinot Noir Crop Estimation Increase Factor Calculator. It will immediately download an Excel file. And this is just a snapshot here of the Excel spreadsheet. And what you have to put in is you have to know 2 things. Your 50% bloom date for the vineyard blocks that you're interested in quantifying. And then the date that you got your cluster sample. So it might be a little small for you guys to see, but it's June 5th would be the day of bloom. And then you have the date of cluster sampling was July 15th. This automatically calculates your number of days post bloom and puts it into the equation. And so I know my increase factor is 2.6. So that's how that's used. So you can download that spreadsheet. Now, when we did this work, a lot of people were questioning, well, you know, does this model work for years with poor set or years that are warm? The answer is yes. We tested that. So before we published this Pinot Noir model, we did that work across one vineyard, same clone and rootstock for all 6 years. And my nervousness was how much does this relate to other Pinot Noir clones? So in 2020, we had a very low set year, and people were saying how they didn't think that their cluster sizes were going to double and that it wouldn't really fit with the model. So I basically tested that. We did the berry development curve in 2020. And in this figure, we can see the 2020 actuals and the model here. And at day 40 on, it matches up very well. So this was Pommard Pinot Noir versus 115 was what we built the model on. But when we developed the model, we didn't fit it tightly to our specific data. We wanted some wiggle room around the idea that it might be good with different clones of Pinot Noir. So we found it worked good on poor set years, worked well in high set years, worked well with different Pinot Noir clones. The question was, can we use this with other cultivars? I know a lot of growers were using this with other cultivars. In fact, many growers are using Steve Price's estimation of lag phase and the increase factors for other cultivars, even from that model. And many extension guides across the US use that same guidance for their crop estimation. So do we know that it fits perfectly? Not necessarily, but that brings me to the second cultivar that we did this for, and that was Chardonnay. So we did this work on Chardonnay. We have not published the model yet because we prioritized the Pinot Noir one, but a lot of the results look the same. So here's 7 years of data collection. We actually got our last data collection year last year. We have some skips and gaps in years, but we took this data from a number of different vineyards over time, and we see that there is a conserved berry development curve regardless of the year here. And we see there's a lag phase, but this lag phase looks a little different than the Pinot Noir one. And those of you who grow both Pinot Noir and Chardonnay, this shouldn't be a surprise to you. So let's look at what the results are. So we see that the start of the Chardonnay lag phase is 46 days post 50% bloom. The middle is 54 days. The finish is much like Pinot Noir and at 60 days post 50% bloom. Now, Chardonnay is a little bit earlier than Pinot Noir in general in this region, so these won't line up perfectly. So they will be shifted a bit earlier than Pinot Noir. The duration of lag phase on average for Chardonnay was 16 days, but a huge range again of between 70 and 20-day range. Again, we had the cool and hot years of 2011 and 2015 in this data set. And we found that the thermal time, so the growing degree days base 50 was 905 on average for that 50% or that midpoint of lag from 50% bloom. And the increase factor models, we're still working on this, but this is what it looks like. Very similar to what the Pinot Noir one looks like. This just happens to show the increase factors based on each one of those crop years. And we've put it into fit it to a model that we've adjusted a little bit based on, that differs a little bit from how we approached Pinot Noirs, and it's a cubic spline model. And basically, there's just differences in how the curve is fit at the prior to 20 days and then the 20 to 30 days. And that is just adjusting the equation that's used in the model. And so what this looks like for Chardonnay, if we look at day count post bloom, much like the Pinot Noir, versus the thermal time. So this is the growing degree days, base 50 post bloom, very similar type curves. The differences are the equations. And for sake of publication, I'm not showing those equations here because we're still working on getting that published. But again, the day count post bloom has a better root mean square error than the thermal time. And so that is, again, showing up much better than using heat units. So if you know your day count or know the dates, basically your date of bloom, 50% bloom, and your date of sampling, we can use day count. And you don't have to worry about having a weather station and those sorts of things to get your increase factor. So what this increase factor looks like for Chardonnay. So if we plug in the equation and we go with, the example here of 30 days post bloom, we have an increase of 4.1. And if you want to wait till, you're into what we would consider that lag phase between 46 and 60, we're anywhere from 2.6 to 1.8. It's not a perfect 2. And the reason for that is because we're looking at these increase factors being for clusters, not for berries. So berries might physiologically double at the exact leg phase, but the cluster does not. It's taking into account all of those berries. So that's why we don't see a perfect doubling. So it doesn't mean that you have to get out exactly at day 55 to get your 2 in there. What this means is you can collect that data anytime in this window from 30 days to harvest and get a good crop estimate if you use this increase factor or the models for increase factors. So what my lab group did was we came up with a way to help growers now plug in an increase factor that's not tied to a leg cluster weight. So you can actually say, cross out this leg word here and say, I'm going to get my cluster weight at 35 days, post 50% bloom. I'm going to plug it into the model and get my increase factor that will give me a good value for that time. And it's a pretty conserved relationship in this data that we've collected over multiple growing seasons. So we feel pretty confident about it. Now, if you want to do a late season check, some of the things we found in our data set, we found that when we reach maximum berry size, and that is at 80 days post 50% bloom in Pinot Noir. So if you wanted to go out and do a validation check on Pinot Noir, you can do it at 80 days with your cluster weights. Now, if you want to do Chardonnay, we don't see that leveling off for Chardonnay. And I think in part, this is because the timing of Chardonnay harvest when we collected the data. They were harvesting at about 100 days, maybe even before 100 days. So basically, we never saw the maximum berry size reached until right there at harvest. So you can use, if you want to do this as a late season validation check, you basically use the same sampling strategy as you did previously at your leg or earlier cluster weights. And then you do it at that later phase to get an idea of how close you are in your estimates. And of course, you can only do this if you're getting a cluster sample early enough before harvest. The next thing that we came from this data set that I think is worth sharing is the fact that we collected all of this data and we have rachis weights. Now, if you do mechanical harvest and you have rachis weights collected, or if you do mechanical harvest and you want to account for the loss of cluster weight due to the rachis, you could build this into your crop estimation equation. And what we found here, so this is the percent rachis weight and the cluster weight and days post 50% bloom. And this is including all data. And we see that at leg phase, at that 50 to 55 days, the rachis is going to be about 6.3% of the cluster weight. If you go in towards harvest, the weight is going to be about 4.3% of the total weight. So you can build that into your crop estimates if you do mechanical harvest. For Chardonnay, we see slight differences. So that 46 to 60 days for leg phase, it's about a 7.4% rachis weight, but at harvest, it's a 4.9. So essentially 5% of the rachis weight at harvest is going to be is going to be that much of your total weight. So again, this has been really helpful to see. It's very conserved, that rachis weight percentage over time. So what can we do to improve crop estimation methods? Well, there's some things that my lab can't help you with in terms of coming up with a greater or improved way to collect more clusters across more space, although researchers are working on that from a precision ag standpoint. But when, if at all possible, try to do a better job of collecting data in the field, record those weak or missing vines, and then make sure that you're collecting your clusters on whole vines, if at all possible, and representing variability across the space that you're in for that vineyard block. Also, if you're going to use the increase factors, it's really important, increase factor models. the equations that we have, you need to observe your bloom dates more specifically. Now, I said you want to record your bud break and bloom. That's because we do have models that are for bud break as well. But I originally thought maybe growers would have better data on bud break. Turns out they have good data on bloom, probably better than they have at bud break. And so I often tell growers, if you want to determine your 50% bloom date, start recording your start of bloom, your midpoint, and your completion, which would be fruit set, and then put the midpoint being about halfway between there, if you don't know specifically what you're calling that 50% bloom. And then use those increase factor equations that we have. So that's publicly available for Pinot Noir, and the Chardonnay increase factor is coming soon. Now, if you reach out to me, I'm happy to give you a beta test on the Excel spreadsheet. Some people have already reached out to me, and I've gotten good feedback even last growing season from people who are using the equation. And so if you want to try it for Chardonnay, I'm happy to share it as long as you use it only for your internal purposes, and then also to report back to me how well you think it worked. And then, of course, one thing that all of this crop estimation work cannot do is anticipate late season changes to cluster weight. So if you do extended hang time, or you have fruit rots or fruit desiccation, that's something that you got to account for to improve your estimations. So if you know that you have rains coming, or you have severe heat and shrivel, that can significantly decrease the amount of fruit that you have available out there, or decrease your cluster size. Now, this Pinot Noir model was released in 2022, so it's publicly available. I can put in the chat box the link to the publication. I'll follow up with with all registered participants who are joining today with an email with a link to the paper, the Excel spreadsheet link, as well as these slides. And so you can use those, and these slides have active links in them. But I wanted to mention that since we started doing this work, and of course I talked about this project before it was ever published, people started using it. We found that more people, when they started using the increased factors equations, they started recording bloom dates more specifically. So it's doing start, midpoint, and end. And we did focus more heavily on the 50% bloom because people felt that was much better to use. And as a result, those who have started using the increased factor equations started doing it earlier. So 10 or even 20 days earlier than they had been previously. And I think that's a safe zone. Trying to do it much earlier, at least with manual cluster weights, doing it much earlier than 25 days, it's going to be hard because there's a lot of shatter that can happen in those first couple weeks after fruit set. So it's better to do it once you're at least 20, I would say 25 to 30 days is probably the earliest you'd want to do a manual crop estimation. So those are, that's it. And I'm going to go to the Q&A and see what questions we have. So there's a question of, would this get good results on old bush 90-year-old vines? Well, it depends on what the cultivar is. I think in terms of having old vines, you might have more variability, and just data collection in general on how you would sample that vineyard. So sampling is always one part of it. The next part of it is the increased factors. Would the increased factors work on older vines? They should. If the older vines are still Pinot Noir, Chardonnay, it really depends on the applicability to those other cultivars. So the next question was, so I answered that one. The next question is, it seems to indicate that the growing degree day accumulation between bloom and veraison has little to do, or has little to no influence on the beginning of veraison. Or am I misreading? Actually, that's a good observation. I think that is what I've observed over the years, is that there's just a time course that is needed in the grapevine. And this has been in both Chardonnay and Pinot Noir, that even if it's warm or even if it's cool, there is a consistent time course to when the grapevine starts to go into veraison. And perhaps that could be partly related to photo period as well. We do see that there's shifts in when we have bloom. And the veraison, of course, is always pushed back, but it seems to be really concerned that there's like this needed time, daytime, not just heat unit accumulation between one pivotal event and the next. And then the next question, it's worth mentioning that if you're picking for sparkling, your clusters will not be at full size yet. That's correct. So they're not, if you're picking at sparkling for Chardonnay, your clusters won't be at full size yet, between 16 and 18 bricks. That's correct. But for Pinot Noir, they could be. So we found that the max size for Pinot Noir was at 18 bricks and 80 days. So it depends on, but if you still use the increase factor equation, and you're pulling it off earlier, you're actually going to have a better estimation than if you leave it out longer. So where we see things break down is when you have desiccation due to hang time. So the question, can the model be used on other red varieties? For example, Syrah. That's a great question. I would say, go ahead and try and see how well it works. The challenge becomes that we built our increase factors on thermal time and day count. And if there is a more significant day count involved, then that could throw things off. But certainly the model is available and you could give it a try. And as I understand it, most people throughout the US, maybe the world, are using a very simplistic parameters at present to figure out what the increase factors are. So, if they're basing it on Pinot Noir, which, a lot of extension guides out there are basing it on the Oregon model, which is the 50 to 55 days post bloom and using a 1.8 to 2 increase factor. So you're welcome to give it a try and then let me know how it works for you. So great question. So how important is it to record missing vines in a block? Well, depends on how you do your calculations. If you're doing your calculations based on, for example, you're assuming that a block that's let's say 2 acres, and you're going on basically linear feet, and you do rough calculations. Let's say that, okay, it's 2 acres, that you have a 7-foot vine spacing or row spacing, and you're going to take your 43,560 square feet per acre and divide that by 7. And you're going to get linear feet of row. And you're going through and you're figuring that out. That's where you're going to miss out on those missing vines. You're going to just make grand assumptions about you actually having that many linear feet of row or vines per acre. So it depends on how you do your calculations, whether you do it on linear foot or per vine basis. But recording the missing vines is important to determine how to adjust your total kind of, let's say, fullness of that area of that block where you're doing your crop estimates. So recording the missing vines is helpful when you're extrapolating across that space, if that makes sense. So great questions. We've got 6 minutes left, so you feel free to keep asking questions. Let's see, we have some. See if I missed any in the chat box. You guys did a great job. You put all your questions in the Q&A. Good work. I see we've got people from all over. So as I wait for people to ask more questions, I'm going to put a few things in the chat box here. I'll stop sharing so I can do that. I'm going to look up the link, give you the link for the website and then the link for the crop estimation spreadsheet. Okay, see another question. So here, this first link I'm putting in the chat box is for our website where you can get access to the spreadsheet. Okay, so this next question, if you do a early yield estimation, do you have to go back during bloom and count again? Would it make it more accurate? Okay, so if you do an early yield estimation before bloom, it's best to do a follow-up post-bloom because you don't know how many of those clusters will make it. So if you do a pre-bloom crop estimate, it's not taking into account actual cluster weights from the year. So what you're getting is just an estimate of kind of an average over time. By doing the crop estimation after you've gone through bloom and actually getting a cluster weight helps you see what is the average that's hanging out there in that year. So hopefully that makes sense. You can ask another question if that doesn't make sense. But generally speaking, you would want to do, I like to do an early season just to get an idea of what fruitfulness is out there. Then you kind of keep an eye on what's going on, and then you can do an actual measurements with the cluster weights. It's good to hear that others are inspired to do the same work other places. It's a lot of work, but it's doable work. So I did all of this work not on grant funding. I basically built it alongside other projects that were funded, and knowing that I had downtime in the lab that, like when students put out bags for stem water potential, they would grab clusters and start counting them in the field. So that's how this all showed up. It took a number of years to put it together, but it's definitely worth it. I'll keep an eye on for a few more questions, and I'll link the Excel spreadsheet. So next link I'm putting in is for the exact, like if you click it, it will download the Excel spreadsheet for you for Pinot Noir. I don't have the Chardonnay one out and available just yet, but you're welcome to reach out to me if you would like to try it. And the next link I'm going to put on is the link for the paper. So that should be covered. If you want to grab those right now, you can do so. I'll see if there's any more questions from the Q&A. All right. Well, thank you so much, everybody, for joining. Great questions. Oh, so the link Excel download has an error, says expired. Ooh, that must be something else, because I know I was able to download it, but I'll send the link to it again in the in the follow-up email to everybody who joined today. Thank you so much. And I'll also have this recording available on my YouTube page for OSU, Oregon State University Viticulture Extension, as soon as it's available. Thanks.